Cool. Welcome, everyone. Every story has to start somewhere. And mine started last year, over a year ago, when I was working in a team where we had multiple teams building independent GraphQL microservices. Now, the context that I'm putting here is that if you're working in an organization where you've got multiple teams building these independent microservices, then Apple Federation might be the right choice for you. And what I found out about that is what I'm here today to discuss my learnings and hope that this might be useful for you as well. My name is Azemia. I'm a father who has a daughter, a toddler, who is the boss of me. She dominates my life, to be honest. I'm also a consultant at Telstra Purple in WA, and I am passionate about building quality products for the users that will make their life a lot easier. It's the first time that I'm actually speaking here at NDC, and it's also the first time that I'm at an NDC conference. A lot of firsts, and I think if I'm not mistaken, NDC Melbourne, this is the first time that it's being hosted here as well, so many firsts for me today. So enough about me. Let's get started to what you're all here about. Hello, I'm Dash. So I'm going to stop with the voice now. But say hello to Dash. Hey, Dash is building a movie video application. He's a product lead of a company that has 3 teams. One of those teams are Azure AWS experts, and the other 2 are Azure experts. So what they're building is we've got the AWS team that's building a movie GraphQL APIs using AWS AppSync. And one of the Azure teams is building a reviews GraphQL API using Azure Functions. And then we've got the identity that's building a user's GraphQL APIs. The idea there is that there will be a mobile application that will be submitting requests to each of those APIs. But before I continue down talking about Apple Federation, I need to take a step backwards and look at GraphQL. So a very long time ago, GraphQL came to be. And then this code came to be on the graphql.org. I'm not going to read all of this, but what I want you to focus on is that bold bit that says, gives the clients the power to ask for exactly what they need and nothing more. Now, that says a lot. And we go a little bit further with GraphQL, where it promises you higher benefits with the idea of having a single graph. You've got a holistic graph where you'll be making your request, and that will equate to where you'll get a single graph and then a single request. So that's the whole idea, right? But then, if we go to look at the graphql.org site, this is what they say what GraphQL is, for those of you that haven't worked with GraphQL. You've got a schema. Basically, it's describing a schema. Here we've got a type called project, and you've got fields, name, tagline, contributors, etc. And the next step is if you want data that relates to that, you can submit for what you want. In this case, we're saying, hey, I want a tagline for this particular project. And then you get a predictable results back. So ask for what you want, and you get what you want, what you asked for. This is another example from How to GraphQL. Basically, what this is saying is that I want to get post followers for that specific user up there. And by that, I'm getting the data back based in that format that I requested it for, right? So if you're thinking about it, we don't know where all of those posts are located, where followers are, etc. And GraphQL is there in the middle, which you can think of it as an API gateway for you. But there lies a problem. We are devs too. And what do devs do? We break things, don't we? As soon as we start working with GraphQL, we start thinking, hey, I've got this whole graph here, but the graph is getting bigger, bigger, and bigger. What if I start creating microservices out of those GraphQLs? So I've got a little mini service here, like for example, movies, and then I've got reviews there as well. And what this gives us is that this multiple overlapping graphs where you get multiple graphs, and then how does your client connect to that? You can have one client connecting to each of those individual graphs. Think about it. You've got multiple teams, multiple development teams, and each one of them building individual GraphQL APIs. Now, going back to this diagram here, I promise you'll be seeing a lot of these diagrams, and it's going to be the nightmare tonight for you, so I'm warning you. So we've got movies, reviews, and users GraphQL APIs. The client is connecting to that. So what's happening here is that instead of having one single graph and submitting one single request, your client needs to know of all of these individual APIs. And that's where the problem is. Your client needs to be aware of all of them. And what if all of those APIs are secured in the backend? Which is the best practice, and you need to make sure it's secured, right? In order to avoid anyone getting your data. So that means you'll need to authenticate against each individual APIs that's up there. And this, you could say, reduces the primary purpose of what GraphQL was built for. And hence, this is where my talk is all about. In order to improve this, what we need to do, the most logical sense, is to add an API gateway in the middle. But how do we do this with GraphQL? Well, the first option that was created was called schema stitching. It's pretty good, and it's been around for a while. The primary purpose of schema stitching is not to focus on the sub-schema like we've got here, so it calls individual APIs that you're building as sub-schemas, and then you've got your gateway schema. The focus is here on the gateway schema. So it's basically just here. Imagine you're building a gateway that will access data from all of those APIs. At one point, it will become overly complex, especially if now we've got 3, but what if we have 10 GraphQL APIs that we're connecting to? So you need to understand each one of them, and then add the necessary resolvers within the gateway. So that means there's a lot of code that you need to add within that gateway. But what if one or two of those API schema changes? It's a breaking change. So that means you need to make sure you understand what the changes were, and then make the necessary changes in your gateway as well. I'm not saying schema stitching is bad. It's still good, it has its own merits. For example, you don't need to worry about any of the sub-schemas, how they're built. As long as you know what the schema is, you can definitely resolve it because there's no dependency on those sub-schemas. But I'd like to introduce you to Apollo Federation, which is what I've been learning a lot about. So with Apollo Federation, we've got a concept called the supergraph, which is your gateway, and then the subgraph. The primary focus of Apollo Federation is on the subgraph itself. So the focus is right here. You don't need to worry too much about the supergraph. That can be being maintained by someone else, but even them, they won't be doing a lot of work on that supergraph because there's a lot of hocus pocus going on in that space, I'm telling you. So that means that you'll be writing a lot less code on your supergraph and focusing only on what you're building, the subgraph itself. But there is a downside with that. Your subgraph needs to understand Apollo Federation. It needs to use some specific directives that Apollo Federation supports in order for your supergraph to be able to interpret that and create your supergraph schema for you. Cool. We're going to dive a little bit more into Apollo Federation, which I hope you're looking forward to that, like my friend here, Dash, who wants to learn a little bit more about it. Awesome. I'm going to kick off with this code from the Apollo GraphQL team. So basically what this is saying is Apollo Federation is a powerful open source architecture that helps you build a unified supergraph that combines multiple independent GraphQL APIs. But the point here is a unified supergraph. That's two words that I want you to leave out with about the supergraph itself. So what does that mean? Within Apollo Federation, that whole architecture that you're seeing here, the subgraph, the supergraph, and interaction with the client application, that's known as a federated architecture. What's cool about it is that you can have as many multiple GraphQL APIs as you want. And all of those can be, their schema can be composed into a supergraph, and that is done automatically for you. So the subgraph itself, which are these, they're your individual APIs that you're building or your other teams are building. And your supergraph here, this is the entry point to all of those APIs. So you're submitting requests to that supergraph, which is then proxying those requests forward to all of the independent APIs. And then there's another concept in there that you need to understand, which is called schema composition. So that is basically the process that gets all of the independent subgraph schemas and then merge them together to form this supergraph schema. So these are the three key items. We've got subgraph, supergraph, and schema composition. And I'm going to dive a little bit deeper into those. We're going to start off with subgraph. And here, think of this. I told you you're going to see a lot of those images, so be prepared. Here we've got three subgraphs, and we're going to start off with focusing only on that movie's subgraph here. So what this is just individual GraphQL APIs that you're actually building. It will have its own distinct schemas. It may contain fields. Those schemas may contain fields that relates to some of the other schemas as well. But the important thing within a subgraph is that you need to be aware is you need to expose the type as entities. It needs to understand those. So I'm going to start this off with this particular schema here, and that's written from AWS AppSync. So we've got a movies Pew GraphQL schema up here. In this current state, Apollo Federation won't be able to interpret this. It may be able to read it, but it won't know what entities are and all of that stuff. So to make Apollo Federation understand and interpret this schema, you need to make sure that those schemas are an entity. And to do that, you need to attach the @key directives here and provide an ID, which is a unique identifier for a movie, for example. You can also use multiple keys or compound keys, which you can look up on the docs, but generally these are what you need at the most important bit. You cannot use object types or even fields that contain any arguments, because that will basically break the whole purpose of Apollo Federation and how it generates keys. The other bit that's most important is how do you fetch related data that exists within a separate subgraph? In this case, we've got the movies subgraph and we've got the review subgraph. We've already looked at movies and it contains types that belongs only to movies. But how does reviews know what movies that it relates to? So what you need to do is within the movies subgraph, you need to create a type that basically contains the ID field, and that type needs to be named movies. And then you need to be able to resolve that type from that review subgraph, from the reviews API. And to do that, what I've done is the top bit of code, that's the GraphQL schema, at least a partial bit of that from the review service. And then we've got the resolvers at the bottom. So within the schema, this is all we need. We need to make sure we've got an ID field that basically maps to the related movies within the movies subgraph. And that's identifiable by the keyword, the directive at external within that type there. And then we're just basically creating a reviews field within that, which relates to the review type within the review service. And within the reviews type, we're basically just creating another field that maps to movie. The next step is to create a resolve reference within your resolvers that basically returns all of the reviews that matches to that particular movie ID that's passing in. And more or less, that's what you need to do in order to resolve the related entities within your subgraph. But the next step is you need a way to expose those entities to Apollo Federation, the Apollo Gateway, so that it understands this. And to do that, you need to expand a little bit more, where you create a union entity type here, which we're saying, hey, these are the entities that I want to expose to Apollo Gateway. If I exclude a director from there, so Apollo Gateway will not pick up director as an entity within that subgraph. It will only pick up movies. And the next step there is you need to make sure you have this type here, which basically returns an SDL field, and that is a schema definition language. And that's a format that the Apollo Gateway is expecting. And the next step is to create the underscore service and the entities field here. These are the two required fields that's needed within your subgraph. And by then, you're mostly done, and Apollo Federation can identify and download the necessary schema and pick up the types that you need from the subgraph. Cool. These are some of the directives that I've spoken about. There are some others, like I've spoken about external as well, which is basically used to specify a field that will need to be used to resolved by another subgraph. Like ID, for example, within our movie subgraph, we've got ID, and within the review subgraph, within our movies type, we've got ID as well. So those relates together. The next type, which is pretty important there, is the provides directive. So that basically states that within your review subgraph, for example, if you've got a type called title, if when you're requesting data there's no title within your review service, what it will do is it will say, hey, I know where to get this title. It's within the movie subgraph, so I can just go there and fetch that from there. And that's what provides means. If you wanted to include the similar field that exists within another subgraph within your own subgraph that you're building. And then another important one, which is here, is a requires subgraph, requires directive, which means that reviews here will be available only if title exists. And you have all of those flexibilities to output what you want to output within your subgraph and when. Cool. We've looked at subgraph, and this is a summary of what I've talked about, which is individual APIs. And each of these individual APIs contains distinct schemas, which may or may not relate to other schemas in other subgraphs. And we've talked about entities, extending entities, and exposing schemas to the gateway as well. But let's look at the supergraph, which is the most interesting bit here. We've got our supergraph, which is our gateway, the entry point to the data that's being stored, regardless where those subgraphs are located, right? And from then on, this supergraph contains a supergraph schema. This is an example of a supergraph schema, which is basically a combined schemas from each of the individual subgraphs, and also appends some of the special directives that Apollo Federation interprets. But the most important bit here that I want to call out is these schemas, you don't need to generate them. It's automatically generated. The first time I saw that, I was so excited because, Wow, just look at that word, automatically generated. You don't need to do anything, similar to how you need to build all of that with schema staging, which is freaking awesome. Initially, I didn't believe it, so I had to test it. You know how we are as devs. And when I got that working, my mind was blown. But how does that occur? There is a process called schema composition, which basically takes your subgraph schema. Once you've updated your subgraph, it basically uploads to Apollo schema registry. And from there on, the Apollo uplink, which is there, is notified, hey, I've got a new schema that's been updated. I need to update the supergraph schema, and Apollo uplink just updates that for you. And then we've got the gateway, which is continuously polling the Apollo uplink. And from then on, if there's a new update, it downloads that, and you can start consuming the updated schema on the client. I'll be going a little bit deeper into that in a bit, but this is how that whole process works. But there is another interesting bit. So we're going to look at how query execution works, which is freaking awesome. So we've got a movies subgraph, which is at the top. We've looked at that a lot, and then the reviews subgraph at the bottom right. And on the mobile app there, we have the query that's saying, hey, I want to get reviews for movies 1. So a request is submitted, and once it gets to the supergraph gateway, what happens there is the gateway creates this amazingly query plan. It basically prepares what it needs to do. Then at the top here, what we're seeing is it's saying, hey, I've got to fetch movies first from the movies subgraph, and then I need to fetch the additional reviews from the review subgraph. How freaking cool is that? And you can actually debug that and log all of that out in your logs if you want to look at it. So the process is this. Based on that query plan, it fetches movies from the movies subgraph, and then get the reviews from the review subgraphs, and returns the data, combine the data, and returns it to the client. Are you excited about how cool is that? You don't need to do anything. So what your gateway looks like is something as simple as this. You're basically just getting your supergraph schema that's been generated, create your Apollo gateway, and then injecting Apollo gateway within an Apollo server. And that's it. That's the basic that you need. But what if your API is being protected by an API key? Well, you can create a little bit more complicated code where you need to inherit the remote graph data source, GraphQL data source, and override the will send request. And in there, you're basically just injecting your API keys, etc. And down here, you're overriding the build service and using the and returning the authenticated data source. And that's more or less it. It's a little bit more complicated than the previous implementation that I've showed you, but you can do that. And the other option as well is you can return responses. Similarly, you can inherit the remote GraphQL data source. Here, return server IDs and all of that. Down here, override the build service again. And then you need to do an extra legwork within your Apollo server and return the correct values add the correct values within your HTTP headers. So that's a summary of Supergraph for you, where it's the entry point of your gateway. And the most important bit is that your schema, Supergraph schema, is automatically generated. Just remember that. The next bit is a schema composition process, which I'm going to go through quickly. So we've got your Supergraph, which is basically downloading all of your schemas from your various subgraph and creating your Supergraph schema. You can do that using Apollo Studio or a tool called Rover CLI. So with that, there are two types of schema composition process. There's a managed federation composition and then a local composition. With managed federation, this is a diagram that I showed you earlier. So what happens is we've got the movie subgraph that gets updated, which basically gets updated in the schema registry. And then that is notifies the Apollo link that, hey, the schema has been updated. Updates the supergraph and then downloads that again. If user's subgraph gets updated, it's the same process again until it gets there, and then go to the Apollo link and then downloads those requests. I wonder, you may be thinking, what if polling fails? Well, there's retries within the gateway attempts to retry about every 10 seconds, but it retries 5 times until if it fails on the 5th time, it needs to reschedule again on its normally scheduled period until you fix those issues that cause that failure. But at that point in time, the important bit is that your supergraph schema remains the version that was there and working, so it doesn't fail completely. It's still there at the previous version that was actually working. This is a summary of a code that I wrote, which is similar to that request that I submitted, that I showed you earlier within that app, and the response on the far right-hand side, and that's in Apollo Studio. So basically, I've asked for movies, and we're getting movies within the movies subgraph and reviews from the reviews subgraph. And it's all in one request. Think about it. Single graph, single request. But it's on the back end, it's multiple subgraphs. So the other process is called local schema composition, which basically we're using a tool called Rover CLI. If you're someone that doesn't want to use Apollo Cloud, for example, where we've got the uplink and the Apollo schema registry, you can use Rover CLI to actually configure the same features within your own CI pipeline. So this is the example that I showed you previously, where we've injected the supergraph SDL within the Apollo gateway. But that's just a string at that point in time. And if we wanted to make Rover CLI work similarly to how managed federation work without using Apollo Cloud, you can do something like this. Where within the Apollo gateway, you can override the supergraph SDL function. There is that function there that provides you with an update function and the health check. And you can create a watcher within that function, which basically watches whenever the supergraph file gets updated, the supergraph schema gets updated. And at that point, what you're basically doing is we're saying, hey, the supergraph schema has been updated. I want to read that file and update the client, and that's it. You can use health check functions there to check if there's any issues with your supergraph schema. If there are errors, then you want to fail safely. But at the same time, your original schema that's working will still work. And then you're basically just returning that. Cool. So this is Rover CLI again, where you can just use a command Rover supergraph compose. And if you wanted to use that within your CI, you can create a YAML file, which is on your right, my left. Confusing. And this is as simple as naming your subgraph, like we've got movies and reviews, and then setting your routing URL where it's going to submit all of the requests, and your subgraph URL where it's going to get your schemas, your SDL schemas. They can be different, those URLs, but most of the time it's more or less the same. You can also use file if your subgraph schema is within your gateway repo. There is another concept before we go into a small demo part, which is called breaking composition. That I think it's pretty cool for you to be aware of. So let's say you've got movies within subgraph A and subgraph B, where release date in this instance, one is a string and the other is an integer. Once you try to compose a supergraph, this will fail because the types are different. Apollo GraphQL compares this to like a compiler error. And this is a quote from their docs. It's basically a compiler error. It stops generating the supergraph schema, but your previous schema that was working is still there and still working. You can still access those. So that basically prevents you from making any errors until you fix that issue. So once you go back and fix that issue with the typing, then with that polling approach that is continuously polling the uplink, or whether you've implemented your own watcher, once that is fixed, then that supergraph schema will be automatically generated again. Cool. We've got schema composition working, where it's basically just composing your supergraph. We've looked at both managed federation composition and local schema composition. But now it's time for a little bit of a demo. So what I have is I'm going to be using Apollo Studio Sandbox Explorer. I've got the supergraph gateway hosted within a Lambda function behind an API gateway in AWS, and the movies subgraph using AWS AppSync. And then I've got the reviews subgraph and the users subgraph hosting using Apollo Server inside an Azure Function. So there are 2 versions of Apollo Federation at the moment, and they're compatible. That's what's awesome. The difference is that with AppSync, it only supports Apollo Federation 1 at the moment. And for the other ones where I'm using Apollo Server, I'm just using, like for the gateway, the review subgraph and users, I'm using Apollo Federation 2. The beauty here is that they are all compatible. Like the directives that you've used in Apollo Server 1, in AWS AppSync, in that movie subgraph is compatible with Apollo Server 2, which is freaking awesome. There are some slight gotchas with AppSync, whereas you need to implement all of these yourself, which I've gone through. But with Apollo Server, all of this is done magically for you. You don't need to write all of those highlighted codes there, which keeps your schema a little bit cleaner, including the resolvers if you need to do any of that. Cool, awesome. I'm gonna quickly go through some demo. I've got about 10 minutes, which should be more than enough. Cool. Right. Looks like my session has expired. Let me just do that quickly. Sign in. Come here. Reload. Cool. So this is a sandbox where I've got currently have movies, directors, and users in here. I don't have any relation to reviews or anything like that. What I want you to see is that there's no reviews. And as soon as I submit this, these are the results that I'm getting back on the right-hand side. And if I dive into the movies type, you can see there's only 3 fields at the moment. I'm going to quickly go through CloudWatch for a bit here just to show you what the query plan that gets generated is. Oops. Wrong log group. So for that query, this is that query plan that I showed you earlier. So this is get generated, which is pretty simple. And Apollo Gateway knows that, hey, I need to fetch those data from the movie subgraph, and that's it. That's fairly easy. But what I'm going to do now is I'm going to go back to VS Code here. So this is the structure of my code currently. I've got a federated gateway project here, and all of those are individual projects and APIs that that's built independently. And then I've got the movies API, which is using AppSync. All of those can be deployed independently as well. So what I'm going to do here, I'm going to go into features. This is currently my gateway, which is what code that I've shown you within the slides. And this is my Apollo stack where I'm building it. So what I'm going to do is just enable this stack, the Apollo reviews here. and just deploy that stack. So what will happen, the expectation is that if the demo gods is with me, is that after this is successful, this deployment is successful, we will start seeing reviews within the Explorer here. So while we're waiting for this to complete, there is one thing that I'd like to show you, which is this bit of code here. So this is basically what's outputting that query plan within the logs. So whenever you want to deploy, whenever you want to test what query plan is being generated, if you want to look into that, you can basically just use that. It's still deploying. I want to also show you the differences between, I've got the movies schema here. And then if we look at the reviews schema, see the difference between the two. The review schema is being hosted on Apollo server. You don't need to add any of those types here, any of those fields here, not even the type, any of this stuff here. So all of these, you don't need. So why this work is if we go inside the index where we're writing the resolvers, let's just close this, move this here. This is done by magic with this function here, which basically builds all of the necessary fields and adds all of those. Now we know that the build has been successfully completed down here, and if we go back here, we're hoping this should refresh in a bit. Ah, cool. See you. It was taking its sweet time. Oh, yes, it worked. Awesome. So we've got reviews here. And now if we go inside movies, where we had that movie previously, you'll notice that we've got reviews here as well, which is awesome. And I'm just going to do that, add those comments and fields, and basically run my query. Fingers crossed. Voila. Reviews is there. And it's all being taken from a separate subgraph. And if we quickly go through to our log groups again, go in here, search for query plan, search log groups. Thought that wasn't working for a minute. So this is what that query plan looks like. It's basically submitting requests to multiple GraphQL APIs in the backend. Cool. How are we doing in terms of time? Awesome. What I wanted to show you as well, so all of this, I think we still have some time, occurs because within the review subgraph here, like I explained earlier, we've added this movie type here, which basically says there's a relationship here with this and the movies subgraph and the movies entity within the movies subgraph there. So all of that magic is done through here, and then we're using the external ID here that says, hey, this is a reference to an external entity, and that's how Apollo Gateway identifies which graph is going to submit those data to and which one it relates to, and then map all of those together with the resolvers. That was it for a quick demo. I'm just going to skip this backup slide where I was going to show a video if my thing failed. I prepared for the worst. Cool. So in summary, your key takeaways are, when building GraphQL APIs, there is a problem if you're building multiple GraphQL endpoints. And you can use Apollo Federation, which has a federated architecture, to build an API gateway in front. And that, with Apollo Federation, there's concepts like supergraph, which is your individual APIs that you're building, including subgraph, which is your individual APIs, and supergraph, which is the entry point to your APIs. And then we've got the process called schema composition, which is that whole process of creating your schema and combining all of them together. And lastly, I ran you through a demo on how all of that works. And yeah, I hope you had an awesome time and you enjoy this talk, and this may be helpful for you. Let me know if you have any questions. Thank you, everyone, for coming. Please. Yep.
Is it when you do the federation and it does off to the first one, which was the movies and the reviews, is it doing that in parallel, or is it waiting for the movies to be returned before?
It's waiting for the movies to be returned, and then it gets the reviews. Because when it submits a request to reviews, it needs to know what ID it's relating to. But within the query plan itself, if, for example, let's say you're submitting a request at movies and reviews independently and not related not within the movies subgraph, so that will send those in parallel. So there are, the way the query plan is structured, there are sequence options and parallel options in there, so all of that is done under the hood.
Right, okay.
What I mean by,
if you had two top-level queries, then they could be independently, that would be parallelized, but because it was a child, it would be...
It will run one after the other in sequence. Yep.
Okay.
You showed queries, but what about mutations? Can you do a mutation across subgraphs?
Yes. Yes, you can. It will work similarly based on where those data are being sent and what's in your mutation subgraph. Yep.
Can you build a supergraph out of other supergraphs?
Yes, but it's not advisable. So the whole purpose of it is, the idea is that you'll have only on one single graph, right? Which is, if you're trying, like I said before, we're devs and we're users as well. So we can make whatever we want, but at the same time, is it best practice? Yeah, so you need to think about that. Yep.
You showed that you could do like a pass-through of an API key to a backend.
Yes.
What about other things like auth and auth? Could you pass down, if you had claims information coming in, could you get that passed down as well? Or
Yeah.
is that custom that you have to implement?
Yeah, for sure you can do all of that. It depends on your own implementation, how you want to implement that. It will be similar, like you can even use OBO, for example, on behalf of if you need to use all of those authentication types as well, so it will work. It just means that your gateway implementation might be different than what I've showed you. Instead of just a basic API kit will be something else based on your own implementation. So that's it, yeah. So like, even the gateway shouldn't be as more complicated as what I've shown you, unless you're adding some weird over-the-top logic in there, but yeah.
So on the back of that over-the-top logic, is there support for applying like policy? Like I think of API management where you can apply cross-cutting policy in that sort of gateway layer. Can you do anything like that with the federation stuff?
You should be. I haven't played around with that much, but based on the docs, it's meant for enterprise, for this sort of enterprise, how do you say it, enterprise approach. So yeah, it should be able to do all of that. But I haven't really delved into that space yet, as of yet. So yeah. Yep.
Another question is that how, like I know you kind of touched on it, but it was the difference between the schema stitching to federation.
Yep.
Are you able to share a little bit more about that?
What do you want to know?
So in terms of like obviously federation and schema stitching, from my perspective, they seem to be very similar.
Yeah, from a diagrams perspective, yes.
But how is it that
So with stitching, all of those schemas, supergraph schemas that I've shown, you're basically writing all of those yourself.
Right, with stitching.
With stitching. So you're writing all of those yourself, and what will happen is that at some point, your gateway will become overly complicated. And if the subgraph, the subschema, as they call it in stitching, changes, there's a breaking change there, you need to understand what those breaking change there, and at the same time make the same changes within your gateway as well, within your gateway schema. But whereas with federation, you don't need to do that, because all you care about is changing your subgraph. And then the schema the supergraph schema automatically gets generated for you. So the focus with federation is on that subgraph. So you as a dev, you're focused on that subgraph and not on the gateway. Whereas with schema stitching, you're purely focused on the gateway itself, and you're writing a lot of code there. And the difference also is with Apollo Federation, you need to add those directives. If you don't, then the gateway will not be able to interpret those, and the uplink will not be able to build your schema, your entities for those. Whereas that's the advantage of schema stitching, is you don't need any of those directives. It doesn't care because you're manually building that gateway. Yeah. So that's the main difference between the two. Yep.
I'll just keep throwing questions. What's the local development experience like for the gateway that sits in front? Like, can you run that locally? Do you own that instance, or do you need to have that hosted by Apollo? And what's it like for local development?
You can run it locally. It's all Apollo server, so you can run it locally. It's not an issue. So it's pretty, yeah. I haven't had an issue running it locally, which is similar to where I was talking about local composition as well, where you're not dependent on that Apollo cloud bit at the top. So all you're doing is everything locally, and you can test that, and then you can generate your schemas within your CI, set that up yourself, so that you remove that dependency on an external cloud provider. So yeah, so you can definitely do that locally, which is cool. Yeah. Any other question? Cool. Thank you, everyone. Happy you've come, and yeah, I'm happy I was able to answer all your questions, which is awesome. Cheers.